Hello, welcome to the 2.4 day 2. Today our objective is to find exact values of trigonometric functions. Now what exact values means is I don't want any decimals in your answer. So we're going to find, say, the cosine of 135 degrees. Now we can type this in our calculator and get some big long decimal, but I don't want to do that. I want to find an exact value that will give me the decimal, like square root of 2 over 2, or negative square root of 2 over 2, or root 3 over 2, something like that. And that's what we're going to learn today. But before we do that, we need to know more about our square roots. I know you've learned this in geometry, but we need to simplify this square root of 8. There's a couple ways to think about it. One way is I take the largest perfect square out of here. Remember, perfect squares are 1, 4, 9, 16, 25, 36, and so on all the way up. The largest perfect square that goes into 8 is 4. So I can say the square root of 8 is the square root of 4 times the square root of 2, because 4 times 2 is 8. Now, I can take the square root of 4, which is 2, but I can't take the square root of 2, so I'll leave that in. So square root of 8 is 2 times the square root of 2. Now there's another way that you can do this. Maybe I can draw a line here. All right, method 2. Another method that people do is you find all of the factors of 8, all the prime factors. So 2 and 4 go into 8, and 2 and 2 go into 4. So all the prime factors are going to be 2, 2, and 2. So the square root of 8, maybe I can do this one at a time, is going to be the square root of 2 times the square root of 2 times the square root of 2. Now, whenever you multiply the square root of 2 times the square root of 2, that's just going to equal square root of 4, which is 2. And we don't have anything to multiply this by, so it gets left alone. So both ways, you get 2 root 2 as an answer. All right, square root of 63. If you know how to do this, pause the video. If not, you can just take notes along with me. If I did method 1, if I look at 1, 4, 9, 16, 25, and so on, the largest number of these that divides evenly into 63 is 9. So this is going to be the square root of 9 times the square root of 7. The square root of 9 is 3. So this is now 3 root 7. If I want to use my method 2, 63 we can divide into 9 and 7. 9 I can get to 3 and 3. So root 63 is equal to the square root of 3 times the square root of 3 times the square root of 7. Square root of 3 times the square root of 3 is square root of 9, which is 3. And then we can get 3 times the square root of 7. Notice we get the same answer. Either way, we do it. Square root of 48. Now the perfect square, again, pause the video. Do the best you can. Now if you're done with this, hopefully you saw that the largest perfect square that goes in there is 16. So the square root of 16 times the square root of 3. So the square root of 16 is 4. So 4 root 3 is my answer. Now if you like method number 2, we can you could pick any number that divides evenly. So you could have just picked 4 and 12. And 4 is 2 times 2. We can circle our prime factors. And this would be 3 and 4, which goes off to 2 and 2. So square root of 48 is the square root of 2 times the square root of 2 times the square root of 3 times the square root of 2 times the square root of 2. Now this will turn into a 2 because square root of 4 is 2. This will also turn into 2. And then we have a square root of 3. Now I can multiply the 2 times 2 to be 4. So I still come up with 4 times the square root of 3. All right. Now we have to look at rationalizing denominators. 5 over the square root of 7. To rationalize the denominator, what I want to do is write this fraction so there's not a square root in the denominator. So what I'll do is I'll multiply by the square root of 7 over the square root of 7. Notice if you multiply by this, you're just multiplying 1, which doesn't actually change the value of this fraction. And when we do this, our numerator is going to be 5 times the square root of 7, and our denominator is going to be square root of 49, which is square root of 49 is 7. So here we have rationalized the denominator because there's no square root in the denominator. Try this one on your own, pause the video, and see how well you can do. Hopefully you're done. If I multiply by root 3 over root 3, now I'll have 6 root 3 over the square root of 9, which is 3. Now we can go a step further because 6 divided by 3 is 2. Now we can't divide the numbers inside the square root with the number outside. We can just divide the two numbers on the outside. All right. Now, hopefully you can do this on your own, so pause the video. Hopefully you are done. We multiplied by root 6 over root 6, and I have 4 root 6 over 6, which this will simplify to being 2 root 6 over 3. All right. Now we're going to look at special triangles. This is a 45, 45, 90 triangle. If I know these two sides, my hypotenuse is going to be times the square root of 2. This is something that you just have to memorize. It's very, very important. The rest of the lesson you will not be able to get through if you don't know this triangle. If you forget, remember you can always do 1 squared plus 1 squared is equal to c squared, or 1 plus 1 is equal to c squared, which is 2. So the square root of 2 is the hypotenuse. Now this is a 30, 60, 90. If we know that's 30, 90, this has to be 60. And if that's 2, that's 1, and this side is going to be the square root of 3. This is also something you need to memorize. The short side is always half of the hypotenuse, and the short side times square root of 3 is the other leg. Again, if you forget this, and you know these two sides, you can do 1 squared plus b squared is equal to 2 squared, or 1 plus b is equal to 4. I need a squared on there. Subtract 1 on each side, and b squared is 3, or b will be the square root of 3. So if you forget this triangle, and you know the two sides at least, you can always find the third. You really need to memorize these triangles. I can't stress it enough. This is the 30, 60, 90, and this is the 45, 45, 90. All right, here are some examples. Can you draw this out on your, I want you to draw this out on your paper, pause the video, and see if you can fill in the other two sides. All right, hopefully you're done. The hypotenuse is twice the short side, which is 10, and this side is going to be root 3 times the short side, so this is going to be 5 times the square root of 3. Now this is a 45, 45, 90. It's, if these two are the sides are the same, we know that these angles will be 45 degrees. So if this side's 5, this side's 5, and the hypotenuse will be 5 times the square root of 2. Here is a 30, 60, 90. So pause the video, see if you can do it on your own. If the hypotenuse is 14, hopefully you found out that the short side is 7. Now I multiply the short side times the square root of 3 to find my third side. Now we're going to do something where, like I told you in the beginning, what our objective for the day is. I want to find the exact value of the cosine of 45 degrees. Now, 45 degrees, if I draw out a little coordinate axis here, is right in the middle, between 0 and 90. If I draw a line straight down to the x-axis, and here's our 45 degrees, I can draw any 45, 45, 90 triangle I would like, and then find the cosine of 45 degrees. I could do 7, 7, 7 times the square root of 2, 10, 10, 10 times the square root of 2. Now, if we keep it here, 7, 7, 7 square root of 2, cosine is the adjacent side, so adjacent to 45 would be 7, over the hypotenuse, which is 7 root 2. Now we can simplify this. 7 over 7 is 1, so 1 over square root of 2. Now I'll rationalize it, so multiply root 2 over root 2, and this is going to be square root of 2. Root 2 times root 2 is root 4, which becomes 2. So the cosine of 45 degrees is the square root of 2 over 2. Now 7, 7, 7 root 2 is not the easiest triangle to do. There's two different triangles that people consider the easiest. One that I like is the 1, 1 square root of 2 triangle. Because if you know this triangle, then you can just see it's 1 over square root of 2, which you rationalize, and it saves you this step here. There's also another way we can do it. If I have my hypotenuse being 1, if our hypotenuse is 1, then we have to divide by the square root of 2 to get these two sides. So it's 1 over root 2, 1 over root 2. Now, this 1 over root 2 over 1 is the cosine. So, so this right here, this x value is the cosine if we rationalize it. All right. So let's go on to the next one. Sine of 135. We have to figure out where 135 is. It's going to be between 90 and 180. And that's going to create a 45-degree angle with the x-axis. Now I'll draw a line connecting it to the x-axis. Now remember, you can draw any triangle. I'll draw the 1, 1 square root of 2. Now since this is moving to the left, we have to call that a negative 1. That's moving up, so that's a positive 1. So the sign is going to be opposite, which is 1, over the hypotenuse, which is the square root of 2. And that's the positive square root of 2. I just got a little crazy with my pen. And again, we rationalize it to get root 2 over 2. So this is the same answer as the previous problem. Believe me, they're not all the same answer. It would be much easier if they were. Let's do cosine of 240. All right, so now at 240 degrees, if I start here, we know that's 0, 90, 180, 270. So 240 would be about right here. So if I drew my right triangle, between 240 and 180 degrees, that's 60 degrees. So we have a 30, 60, 90 triangle. You can draw any 30, 60, 90 triangle. I like the 1, 2, root 3. And we have to check our negatives. This goes to the left, so that's negative. This goes down, so that's negative. So the cosine of 240 is going to be adjacent, which is negative 1, over hypotenuse, which is 2. So that's negative 1/2. Let's try tangent of 225. Pause the video, see if you can do this one on your own. 225, again 90, 180, 270, 225 is going to be right here. If I did the tangent, we know this is 45 degrees, so this will be 1, 1, root 2. If I check my negatives, that's going to be negative and negative. So we're going to do opposite, which is negative 1, over adjacent, which is also negative 1, and negative over negative will just be a positive 1. So the tangent of 225 is positive 1. All right, cosine of negative 60. If you can do it, pause the video and see how well you do. All right, negative 60 degrees, instead of going around this way 60 degrees, now we're going to go backwards or clockwise 60 degrees. So I'll say it's somewhere about there. I'll plug in my 60 degrees. And now if I put my sides on the triangle, it's going to be 1, 2, root 3. And now let's check for negatives. This moves to the right, this moves down. So that's going to be negative root 3. But that's not going to affect with cosine because cosine is adjacent over hypotenuse. So that's going to be 1 over 2. All right, sine of 330. Again, try this again by pausing the video. 330 degrees, 0, 90, 180, 270, 360. So back 30 degrees from that. And the opposite is going to be 1, 2, root 3. Now we'll check my negatives. That's positive, and that would go negative. So for my sine, I do opposite, which is negative 1, over hypotenuse, which is 2. All right, one more. Tangent of 315. 0, 90, 180, 270, 315. Now if I label my sides, 1 and 1, and root 2, where this side is negative 1. Now, because that's not a root 2. There's a root 2. All right. So now the opposite is negative 1 over the adjacent, which is 1. Negative 1 over 1 is negative 1. All right. So hopefully you can do these. Well, now let's do some of the newer values. Cotangent of 150, 0, 90, 180. We need to come back 30 degrees. So if I draw my sides, that's going to be 1, 2, root 3. And this way is going to be negative root 3. So cotangent, we know tangent is 1 over root 3. So cotangent is going to be negative root 3 over 1. So negative root 3 over 1, or just negative root 3 for an answer. We'll try one last one. Cosecant of 225. So 225, we have 90, 180, 270, 225 comes back here. And that would create a 45-degree angle. So we'd have 1, 1, root 2, where these two are negatives. Now, cosecant matches up with sine. Sine would be negative 1 over root 2. But cosecant is the reciprocal of that, which is root 2 over negative 1. So if we divide that, it'll just be negative root 2. All right, hopefully that's enough to get you through the homework. Good luck.